Now we're going to take a look at how to multiply two polynomials together. In this case, we're looking at two binomials. 2x minus 3 is the first binomial, and the second binomial is 4x plus 10. Because there is no addition or subtraction in between the parentheses, that means we want to multiply these two polynomials together. To multiply them completely, we think of this as a big distribution problem. The 2x inside our first binomial has to be multiplied by everything inside our second polynomial. Therefore, we're going to distribute 2x to both the 4x and to the positive 10. So we have 2x times 4x and 2x times 10. It's simply distribution, just as if it were a monomial. Then we have another term here inside that first binomial, a negative 3. That negative 3 also has to be distributed or multiplied by the 4x plus 10. So we have negative 3 times 4x, and then the negative 3 also gets multiplied by the positive 10. Now we multiply. 2x times 4x will be 8x squared. X times x gives us x squared. Then 2x times 10 will give us a positive 20x. Negative 3 times 4x will give us a negative 12x. And negative 3 times 10 is negative 30. Now if you look closely at your answer here, you should see that we have two like terms. The like terms are the 20x and the negative 12x. Because those two terms have the exact same variable to the same power, we can combine them. And 20x minus 12x leaves us with 8x. So our final answer is the 8x squared plus the 8x that we get from combining the two like terms minus 30. Here's a second example that looks a little bit more complicated than the first one, but the same principle applies. We now have a binomial, the two terms 2x plus 4, that we want to multiply by the trinomial x squared plus 6x plus 9. In order to do this, we simply distribute. We start off with the 2x, that leading term, and we're going to distribute that 2x to everything that is in the trinomial. The 2x has to be multiplied by each individual piece. So 2x times x squared, then the 2x times the 6x, and finally the 2x times the negative 9, the constant term in the trinomial. Once we've distributed that, we have another term here that must also be distributed, at positive 4. So the positive 4 gets multiplied by the x squared. The positive 4 gets multiplied by the 6x. And also by the negative 9. Now we multiply. 2x times x squared is 2x to the third. The next piece, 2x times 6x, will be 12x squared. Then we have 2x times negative 9, negative 18x. The next multiplication is 4 times x squared, which gives us 4x squared. Then 4 times 6x is positive 24x. And finally, the 4 times negative 9 is negative 36. Now when we look through this result, we should see a couple of like terms. The first pair of like terms that we notice is the 12x squared and the 4x squared. They have the same degree, so those two pieces can be combined. In addition, we have negative 18x and positive 24x that are the same degree, so those like terms can be combined as well. So to get our final answer, we have 2x to the third, because that's the only x to the third. There's nothing else that's like terms with that. Then we go to the x squareds. A positive 12x squared and a positive 4x squared will combine to give us a positive 16x squared. Then the negative 18x and the positive 24x, or if you prefer, you can think of it as minus 18x plus 24x. That will combine to give us a positive 6x. And then the negative 36 at the end can be brought down. There's no other constant term that can be combined with it. So our final answer is 2x to the third plus 16x squared plus 6x minus 36. No matter how large the polynomials we want to multiply become, we can repeat the same process. It is still just basic distribution. The only thing that changes is the number of terms that must be distributed. For example, in this trinomial that is being multiplied by a trinomial, 3 terms times 3 terms, we would start off by distributing each of the 3 terms in the first polynomial to the 3 terms in the second. So to quickly go through this, we would multiply 4x squared times each of the terms in the second polynomial by the 3x squared, by the negative 5x, and by the positive 3. So that is the 4x squared multiplied by each of these terms. Next, we would multiply the x times each of those terms. So x times the 3x squared, x times the negative 5x, and x times the 3. So that takes care of the first term and the second term. Now we have the negative 2 left, so we would multiply the negative 2 times each of these terms as well. Negative 2 times 3x squared. I'm just moving to another line because I ran out of room. Negative 2 times the negative 5x, and the negative 2 times the positive 3. The multiplication works the same way as we've been doing. 4x squared times 3x squared will give us 12x squared. The 4x squared times negative 5x is a negative 20x to the third. Then 4x squared times 3 is a 12x squared. Next multiplication, x times 3x squared will be 3x to the third. X times negative 5x is a negative 5x squared. X times 3 is 3x. And down to the last bit of multiplication, negative 2 times 3x squared is negative 6x squared. Negative 2 times negative 5x is a positive 10x. And negative 2 times 3 is a negative 6. Looking for like terms, this should have been 12x. Oh goodness. 12x to the fourth. X squared times x squared is x to the fourth, so let's fix that. The like terms that we see, we actually have a few more here. We have the negative 20x to the third and the 3x to the third. There's nothing else with the matching exponent, so those are the only 2 like terms that are x to the thirds. Then we notice we have a positive 12x squared, a negative 5x squared, and a negative 6x squared. Those are all the same degree, so we have like terms with them. And then a positive 3x and a positive 10x are like terms as well. So the things that are like terms we can now go in and combine. Our final answer then is 12x to the fourth. The negative 20x to the third and positive 3x to the third will give us a negative 17x to the third. The 12x squared, negative 5x squared, and negative 6x squared will give us positive 1x squared. And remember, we do not need to write the 1, it's an understood coefficient. And then the 3x plus 10x is 13x. And the negative 6 has no like term, so we bring it down. Our final answer then is 12x to the fourth minus 17x to the third plus x squared plus 13x minus 6. So the basic principle here is anytime you are multiplying any type of polynomials, you distribute each term at the beginning through every single term in your second set of parentheses. Once that distribution is done and your multiplication has been accomplished, check for like terms. Anything that is a like term can be combined, and you have your final answer.